Online, you're supposed to see. Oh, yeah. I know, I have to look at this online. Yes. Okay. Now I can see. I've got none to and one to the chat. So I mumble to myself, so you know that I'm actually alive and kicking online. Okay, I will warn you now. I will be moving anyone in the back half of the lectures theatre to the front half now. Seriously, if you're in the back half, you will be moved to the front half. So I suggest you choose a preferable location now that's not in the back half of the. I'll explain why.
Morning.
Early. There's actually no mic too, which I thought we had mics. Do. Hey, I'm so sorry. There's a transcript. Let's try the chat. Yeah. Okay, apology online. She speaks, yes. But you know, they're in there. I do that to people sometimes to harass them. So yeah, I was not speaking. Yeah, the apology online and on recording. So that means none of that was recorded. You can't actually edit these videos. I just want to remove the front bit. Sorry, online. I just want to check something. Yeah, that's from. Yeah, all the time. wrong class, too many. Oh, that lecturer on her again. Down the front row, please. Front row, please. Because yeah, yep, okay, and front row. Sorry, I do know your name. Up the back row, you'll have to move forward. You have to move forward, sorry. I do know your name, sorry. And I've forgotten. The reason is, it's hard to keep people's attention when you're teaching, particularly a lot of content. You'll lose your attention. If you're closer to me, you'll pay more attention, it'll help your learning. You need to learn this unit, it's a lot of content. So yeah, do the pre-work, you'll get put into groups based on the pre-work so that you'll be at the same level so you can support each other. It's cooperation, not collaboration so much in the assignments. So you probably allocate different questions to different people and then share the ideas. The unit's described a lot. Please read this document. Don't go to the back row, please. Sorry, you'll be put in the front row. Thank you. It's just really hard to concentrate from the back row. Good luck trying. So the assignments. There are fortnightly assignments. You've been warned about that. Please do not complain that there's nearly weekly assignments. They're fortnightly, which is a slight difference. There are certain requirements to assignments, such as you'll be marked for your working. The reason is if you get the wrong answer, but you've got the working, you'll get some marks. If you get just the answer without the working, I don't know if you copied. So it gives me a chance to just say, even if you have copied the answer and then work towards it, at least you've learned something. So we're trying to assess your learning. If you don't, these last semester, and I'm warning this because some of you I taught last semester, they were project-based units. They're quite different. If you're doing a project-based unit, you can learn along the way and finally achieve the learning outcomes at the end. So I did certain marking, which I said, if you don't do this, you'll get 0 for that aspect, and people got 0. And immediately I warned you, if you do that certain aspect later, you'll get the marks back. I told people. I still had a complaint that I'd taken the marks off, but anyway, I told you I'd bring them back. Now I won't. If you do not do what I say in the rubric, in the submission link, you will get 0 for whatever it is, like 0 if there's no half marks for no working, whatever. I will not change that mark. Partly because the class is much too big, partly because each assessment is testing something else, some aspect. We've got a lot to learn, so I'm testing along the way, which means you don't have to remember it very long. Aren't you lucky? But also I will test you at the end in the oral, have you got the main concepts? So I want you to do these exercises and just practice and show that you can practice at least once what I'm teaching. And then at the end, I'll see, have you got an overview of the unit? I know that a lot of you are coming here to get a visa. You're not particularly motivated by the units. So I want to motivate you more by the units to get something out of them, to learn something, to come out of it with the skills that you need for the job that you need for your visa. So it's all very practical and focused and reason for everything. So anything you've got a problem with, put in ask here, why is she doing this? She speaks. Oh, why is she doing that? So that I can answer you and explain, because there's usually a reason. If there isn't, well, then I might change. Might have to change it. So yes, assessments. I got teachers' responsibility. Are there extensions? To get an extension for an assessment, You must use the extension system, which is under the assessments. I'll show you that later after this. You'll get 10% per day, all part thereof, reduction in marks, in my reduction of your total, not the achievable total. If you're in the back row, I'm going to move you forward. If you're in the back row, I will move you to the second front row. So you can move or I will move you. Thank you. You can't come late and stick to the back of the class. Just because this isn't good for learning. Yeah, so extend 10% per day or part thereof. So we want you with a camera and mic online. It'd be nice if you actually showed your face when I start showing that screen, but anyway, it'd be nice to have people online and it'll engage you more. I can start engaging with you. Back row, I'll move you to the front row. Back row, I'm going to move you to the front row. That's why the back row is empty. It's not natural to have empty rows in the class. It's obviously enforced by a dictatorial lecturer. Yes, thank you, Evan. Yeah. Carl, sorry. I'm going to get the names right. That's it. Back row, I'll move you forward. Anyone in the back row, the reason they're empty is because I will move you forward. The other part is I want you to sit closer to other people. I want you to talk to your peers. I don't care if you mutter over me or that allow to make the people, if people around you are talking too much, stick up your hand because I'll shush them. But generally I won't shush you because you might need to ask questions and there are people around you to ask questions of. You're still pretty far back. Anyway, so there's my responsibilities. I'll answer questions in Ask Here. So put your questions in the Teams channel Ask Here. There's Teams. There's Ask Here. I'll answer questions in that. From now on, I will not answer any emails. And if I do, it'll probably be a week late. I'm sorry. I answer at least 150 emails a day. The others, I don't have to answer much. So realistically, it's much more effective if you ask me and Ask Here. The thing is too, I'll swear there is nothing that you can ask that someone else wouldn't ask as well, or want to ask but too shy to ask. Now, if you're worried that putting something online, it might be a private matter, it might be detrimental to you. One thing too, I've got a rotten memory for people who annoy me. You can annoy the hell out of me and all I remember is, oh yeah, you're a student in my class. So you can annoy the hell out of me as much as you like and I'll growl at you. And next week you come in, oh, sorry, miss, I was the one. I go, oh, were you? I literally do not remember because I don't care. Once I've growled at you, once I've told you, you know, it's all done. So please put things in Ask Here. Please do ask. If you also, you can answer your peers. If I haven't answered in a day, so do throw an answer in, that's great. And it gets, if there's anything that's really private, what do you say? Oh, miss, if I'm sick, what do I do? You don't say, oh, miss, I've got this terrible disease, blah, blah, blah. No, you don't have to put the details. So you can generalize it, things like that. So please use Ask Here. Yeah, we also need professionalism from students. Do not abuse your teammates. If you're in a group and someone does something you don't like, ask them why they're doing that. Say you don't like it. Why are they doing it? Maybe there's a perfectly good reason they've done something that you object to. They have totally different reasons. I know it's hard dealing with people, particularly from different cultures. I deal with it all the time. My culture is not particularly dominant in Australia. So be sympathetic that other people have different values, different ways of seeing things. Do not abuse people. And particularly, do not abuse me. In week 3, I will put out a survey to get feedback because then you can change the course that you're in, not the one that someone else gets next year. I need feedback that's constructive, that tells me what you're experiencing that you need changed. If you just abuse me as disorganized, I'll get the online site's disorganized. We have learning experts that go through the online site, so they're checked. We know what we're doing. We're doing our best. And obviously it's not going to suit everyone. And we change things each year. Have we changed it for the worse or change it for the better? So please do give feedback that's constructive. Miss, I use videos much more. I find it hard, so then I'll re-emphasize the videos. Miss, I need more exercises. Well, I got that last year, so the exercises are much more embedded in the slides. So we're doing changes, but please keep telling us what you need changed. But don't criticize me as a person, because all that does is stop you learning. I am not here for a popularity contest. Lots of people do not like me. Does it matter? You mightn't even like my teaching style, but that's what you're getting. So make the most of it. Yeah. Because, you know, I hope you get a lot out of this unit. It covers a lot, and it's some that's really quite, well, it's very useful for programming. It's very.
Hey, there's no audio again, Kat.
Kat, I think you are muted.
You muted yourself.
Why is that? LearnLine class. Thanks, Ben. How to get muted? That's, yeah, that's weird. When was? Thank you for watching. Yeah. Ben. Yeah. LearnLine class. Okay. Thank you. I'll get on there and just warn them. I can't actually disable it. Whoa. That's not great. What did I click? That's, oh, there we go. I'm probably click. No, I need help. I'm not really watching what I'm doing. Allow. Yeah, I was probably clicking that. Okay. Communication. Oops. Go away. Close. I don't need tutorial. For those all in the Collaborate, we do not use Collaborate. Invites to MS Teams was sent out. James, what are you doing in? Look, the beginning of this year, a message came out that we will not be using Collaborate, we'll be using Teams. So I switched to Teams, and next thing I know, the Collaborate class was open. So that's why I'm a bit slow on realizing Collaborate. Oh, you're not hearing me. Why Collaborate is open. We are on Teams. The invite was sent out. The link's on the front page of LearnLine. So please go to the LearnLine site. I could share with you. If you look on the LearnLine site, down the left-hand menu, there is, I'm not going to share with you. Can I share with you? Where's the share? Share screen. Yeah, please, James. What the hell are you doing there, James? You know I'm a Teams teacher, just because I was told to. So share application screen. Share. And it's going to see how, so down the bottom is this Open Teams meeting, and you get the meeting will come up. Oh, that's a joke. Sign in. So please go to the Teams meeting. Thank you, Ben. Okay, so what I've been going through so far, oh, just a sec, are they still there? People, 10 people. Please, all of you online, hey, so you're all AWK, nice. Move from session. For those who are not at their desk, dear. Mitchell, you know I'm on Teams. Maybe I'm on both, hopefully already. Okay. And if I don't think they can get back in actually, but just a whiteboard, blank whiteboard. Loading whiteboard. Learn line. I swear I'm typing learning, learn line. Okay, now I'll leave that and hopefully, yeah, well, the mic's on, so hopefully. Yeah, probably should, oh no, that'll wake them up at least. Okay, so read the semester 2 document. This describes all the course, your requirements to be professional to each other and to me, otherwise it'll affect your learning. Online, please have a mic and camera. I want more engagement. Unit assessments. So the first assessment was open as I sent out. We'll cover this in the first lecture and the second lecture. It's due before the third lecture, which is on a Wednesday. So what's happened Friday in 3 weeks is a public holiday. Friday in week 6 after the break is a conference that I'm at. So both classes will be on the Wednesday that week. Sorry about that, but best we could do. I wanted to bring you in during the break, but I wasn't allowed to, so aren't you lucky? So assessment 1, I'll be covering in this lecture, next lecture. I don't open assessments usually more than 2 weeks before they're due. Oh, this is just a question sheet. The submission link is under assessments. So unit assessment. Oh, unit assessment. Sorry, oh no, that's the submission link. Sorry. The questions are under the week's work and the assessment is here. People have asked that I not put them in both places because sometimes I put an old version somewhere, but also it's clearer. So I will go through the question sheet. This will be on this week. I'll show you. If you need an extension, the reason I don't put them up except 2 weeks before is A, you'll panic because you haven't heard anything about the material. And because of Sydney class, I actually have to put on a bit earlier for you, but please don't panic. Don't expect you can answer the questions until at least the first class, and then there's the questions after the second class. So we're not expecting it. Otherwise, you panic and you go to Chegg and you go to Evers and you copy. And I will be checking most of those sites to check that you haven't used them. I'll be doing plagiarism checks. I'll be checking that you've done the answer. But most importantly, I know from graduating students, please, can the back row people move forward now to the front row? Back row, front row. Yep, 4 of you, move down. Thank you. Yeah, because the experience from graduates that I know looking for work, those who have cheated know they don't know the material. They know they won't pass an interview and they don't even apply for jobs. So I know a lot of people now who are not even applying for jobs, they're just staying in hospitality because they know they cheated their way through and don't have the knowledge. Why waste your time? Use your time well. Yes, the questions are difficult. Yes, you might fail an assessment and then you'll get feedback. So you'll actually learn and the next assessment will be easier. And then you go into team assessments where you got the team to support. In fact, you'll have a team probably from next week. So you'll have your team to support you and help you. You can talk to them as much as you like. Just you write the answer yourself. So same as in essays where you can discuss the essay ideas with your class, then you write it. yourself. And that's all I want. Even if it's someone else's idea of how to solve it, you've absorbed that enough to write it out yourself. So please avoid cheating. It doesn't help you in the long run. So material for learning. I've got this here, which has a lot of things like videos. Oh, these are programming tools. So help you learn Python. These are visualizing data structures, so you can actually play around and use the data structures that I'll be teaching you about. So it's a really good tool to play with. And there's videos covering the unit topics. A couple of them are about an hour long, one about 4 hours. So it goes across the whole ambit of what I'll be covering, but obviously I'll do more detail. So it's a good thing to look at now and then for summary. Also, they might be from your nationality, which might help you understand them better. Things like that. The language might be easier. Sample problems I've got up there, etc. So this unit is about algorithms and complexity. Whatever language you program in, algorithms will be the same, just you'll write them differently. So a loop is generally much the same in Java, JavaScript, Python, C, C#, C++, etc. So the whole concepts are the same, just how you write the syntax will be slightly different. A couple of the words will be expressed differently, etc. Same as if you're working with languages from the same region. You know, basically they're languages from the same region, which is the computer world. So they're all very similar. So I am teaching language agnostic. We like you to do your exercise in Python. That's why I have the textbooks in Python, because Python is one of the things we teach. Python is very useful now. Python is used in machine learning, AI. It's used in language analysis, which I do. And so it's something we think it's worth learning now. It's a language of the present. And syntactically, it's quite easy. I recommend you use Visual Code Studio if you're doing Python. Don't use Atom. So use this Visual Code Studio. I'm just going to check if there's anyone in there now. Yes, there's 3. Sorry. Yeah, that's the problem having it open. It's encouraged people in. So I will leave now. You don't have to do it in Python. I've had people do this unit in Java. I've had people do it in pseudocode. And that's the point. A lot of you won't have coding background. You've perhaps never coded. You've never had to deal with the pedantic nature of the computer. And this is partly why you find me very pedantic. You know, move to the front, move to the front, pedantic, blah. I am used to communicating with computers a lot. That's how I think. I think rather like a machine, and I'm trying to get you to think like a machine, because the more you think like a machine, the more you can communicate with a machine. So if you want to do pseudocode, I am quite happy. You will get at most probably 3/4 marks for assessments. I think it's the way I can't remember how I do it this year. But because if you're doing coding, you've got to do debugging, and it's actually a little bit more step involved. So you're taking a bit of an easy path. However, your pseudocode is what we would use for comments. So if you're a good programmer, which probably I'm not, and most people aren't in industry, but if you're actually a good programmer, you will pseudocode first. So you'll say, work with your team, oh, this is the problem, this is how we solved it. You do a pseudocode, the rest of the team can read it and say, yes, yes, that's the way we're doing it. Then you code it. And the pseudocode remains. The pseudocode is your comment. So you literally have the pseudocode and you start writing the code in under it. You know, this routine, method, class, whatever, well, no method or routine, will take in these parameters. So you write that and you just find the parameters, specify how much you have to. Then you say, and this routine will do this. So write the code that does that, step by step. So pseudocode is actually the initial step of programming. So I'm very happy if you do pseudocode, as long as you remember for the rest of your life that you pseudocode before you code, and you then expand it with your code. So it puts you into a good habit if you start with the pseudocode. I think, IoT Club has been set up for those who are interested. It's on there to join. This is actually old one from that. Yeah, sorry. Oh man. Oh dear. Please share the screen. I'm just not watching this thing. Oh, thank you. Screen or tab, document, and survey. I'm just stepping through the online section. I'll try and record the beginning of this lecture. So under material for learning, we've got these examples. It's because I shared the other one. I knew I'd bung her up if I did that. Videos and yeah, the IoT Club. Also, so the IoT Club, you might want to join. I encourage you to do more programming, more use. Susan Gallagher from the library does a lot of learning support. If you're having trouble with English, writing English, reading English, hearing English, do go to the library learning support. That was for me and Liji. What else I was going to go about? Good. Oh yeah, I can't spell learning. AI tools. ChatGPT is a brilliant programmer. ChatGPT will improve your programs. You can ask it many things in programming. That's fine, but you'll have to comment it. So you'll have to write the pseudocode into the code. So again, your code will have to have comments. A lot of the things I do could be done by ChatGPT, I'm not always. If you use ChatGPT, check it. Like I said, I don't care if you do get your answers from the web. Most of my code comes from SourceForge, those sort of sites. Very handy. And then you adapt it to this particular application you're doing. If you can read the code and adapt it, that's all you need to do. Yeah, I'm an open source programmer too, so I use other people's frameworks. It's much more efficient. So, yep, this is just a bit about AI tools, how to use it responsibly. Do not, just as a warning, do not write a report in ChatGPT. Don't expect to take a report from ChatGPT and submit it. Do you know the glaring problem of ChatGPT in writing reports or writing essays? Anyone know? It makes up one particular thing. Do you know what? The ChatGPT is predictive. So it says, okay, after this word, the most likely words are. And it gets into the topic that you've asked and it knows what's like to be in those topic words are and how they follow each other. And yes, it does a brilliant job. What is the reference that follows your words? It can't find a reference that would be relevant, so it makes it up. So we get these amazing references by authors that we don't know in our field, writing, it's actually sometimes they're papers that really could be written. They'd be great papers, lovely titles, but they don't exist. So if you're going to write an essay in ChatGPT, please do some referencing. You'll have to go back and reference it. Just a bit of advice. So I'm very happy that we use AI in learning, but do not rely on it. And also, I mean, if you do things like get ChatGPT to improve your program, great. Look at what it's done. Learn from it. Now, it's experienced in programming more than you are, so let it teach you. No hesitation. Attendance. Okay. Oh, I was supposed to do that at 1:15, so now it's closed. No, not online, Outlook. Anything but online. Oh no, I'm gonna have to log in. Oh, sorry. I promise, in future I'll be more organised, but I hope to have the mic on too. Yeah. Oh, not create account. Okay, portal. I'm rely on Google to remember me all the time, and I am logged in. You think it'd remember me, but anyway. Where's online OneDrive? forms, forms. So this is settings. Oh, maybe later. Go away. Settings. Yeah, it makes up sources. It's bizarre. It's just really amazing how it does it. So it's 9:10, so I'll just make it 9 o'clock till 9:15. And I'm going to stop sharing. And you can, oops, please scan. Let's see if it works. From back there, can you scan it? Let's see if I zoom. Control plus, yeah, oh yeah. So what did I do? This way I have it, I export it from LearnLine anyway. So this way I have it. The thing is, Sydney and us have the same LearnLine attendance. It gets a real mess. So you attendance will not show on LearnLine. Apology. I'm not going to import this into LearnLine. You have to do it manually. But I will have a record every week of who attended face-to-face. Is it working? No. Anyone not getting on? So all it asks you SID because you have to be logged in to the portal. I'm just trying to encourage that. Do not use your personal emails. Always log in through the portal. Use authenticated access. One thing too, people have been forwarding their email. Actually, it's only like 3 students. Do you all forward your student email to your personal account? Yeah, this is weird. 3 students keep kicking back. And when I go to IT, they say, oh yeah, they're forwarding their email to their personal. I go, well, everyone does that. You forward it all to one email account. I do email you and say, please, you're kicking back. It's really worrying because we keep getting kickback from students when we send out notices, and then we think, okay, it's the same one, probably they're getting it, but we don't know. So please fix your forwarding so it doesn't kick back. Anyone still need to log in, register attendance? No, okay. No, I haven't because I'm doing the attendance. So it was deliberate. As I said, I did announce that one, mumble. So now I'm sharing again, yep. Okay, so material for the week. Oh, sorry, yeah, assessment extension. So I didn't mention that. When you do assessments, if you need an extension, this is the process. There's a form, yeah. Okay, so I've got to not share again. Where are we? Stop sharing. Sorry, I didn't miss you. Where are we? Attendance. Way down. Attendance. Yeah, stop sharing. I have to stop sharing. Oh, content items loaded. Okay, go away. Is it working? It should work for another minute. You got another minute. Everyone happy now? Okay. All happy?
See it.
Hilariously happy? Good, great. Okay, yeah, then I can share again. Oh, just so I can make it a bit smaller. Sorry. Sorry, you need to stick up your hand so I can see. I've really got to get on. It's going to run out, and I'm not going to fiddle with it again. I don't know if it's still alive. You can't do it on someone else's phone unless you re-log in. Yeah. Yeah, it can only be your phone. Yeah, that's what I said. It's going to close in 1 minute. Sorry, all done. I'm not fooling around anymore with it. We'll look at that later. But you have to use your own device. Oh, you can't use a computer, can you? And you don't have a phone. Okay, well, it was accepting for 10 minutes, so. Okay, sharing screen. Now, okay, I shut that, didn't I? So, come and see me after and I'll put you on. But you have to put yourself on, but I'll do it after. Okay. So Ipswich material is up at least by the previous lecture. I asked you to look at it. Maybe you don't make much head or tail of it, but you will see like there's pre-work you needed for week 1. There's an overview page or something similar which says what we'll be doing this week. Oh, sorry. Yeah, I did cover that. I think I was in the middle of that, wasn't I? With the unit assessments, make sure that you put in for the extension. Otherwise, I will not give you any consideration. Do not come to me and tell me about your problems. Yes, that's really bad that you've got these problems. I can do nothing about it. All I can do is give you an extension, but I require proof to give you an extension. Who can help you is a counsellor or a doctor. And this is why I'm really strict about this. I refuse to give you an extension because a lot of crap happens in our life and you need to deal with it. Get help. Do not think you'll just puddle along, delay this, delay that, you'll come out better. Probably getting help will be much more effective. So that's why I'm really strict about it. No, I'm not going to give you an extension. You've got to go and get help first so that it won't delay you any longer. So please do use the extension system. There's a form to fill out and you submit it. So I kept getting interrupted on that one. So please do. So we've got the overview of this week was looking at complexity. What is complexity? The reason is with programming, the main aim is to improve your programming, always. So your programs can run faster, they can run more efficiently that way, speed or space efficiency, and that's the complexity of your program. How complex is it in terms of time or space? And that's basically what we'll be doing, counting the number of steps your program takes and reducing that number of steps it takes. That's all. So we'll spend about 12 weeks doing that because there's different types of programs, different ways of doing it. There's lots of different structures you can use to be more effective. At the same time, we're learning how to program. And there's different data structures. Please don't sit up the back. Please move down. All in the back row, move down. Yep. The reason now I'm moving you is so you sit near someone. Yes, okay, just sit near someone, I'm happy. Thank you. So you can talk if you need to. So the other thing is how improving program can be the data structure you use is more effective. But then that's the complexity of the operation on that data structure is less. So it's much the same thing. But we give you a whole different range of data structures you can use. And so you'll go through this semester and come out the end totally bemused and stunned and remember very little of it. But what you might remember is that these data structures exist, and you can go back later and start using them when you think they might be. So some of the questions in the oral will be, I'm doing this sort of operation on this sort of data, what structure would I use? And it'll be the main structures that I've taught you. So be aware when I start talking about new structures, how they're used, when they're used, what's the advantage of them. So you're always looking for improving your coding. What way would we improve it? No, oh no, Ben, don't worry. Oh yes, you're right. You cannot see attendance. Oh no, you can't. No, you're right, because it's for a face-to-face. Sorry, Ben. Yeah, I don't mark attendance. I don't mark attendance online. I might try and do that when we have a break. I'll try and do that, but it's not so important. Attendance online is not crucial for your requirement of a test attendance. Online is not attendance in class. Sorry, that's it. You have to be face-to-face. But it is good for me to keep record of people who come regularly. So that's how I know Ben. He comes regularly. So things like that. And then when crises come up in your life, I go, oh yeah, that person is trying, that person is attending. It matters. Great. I'll put more effort into it. I'll be more conciliatory, etc. If you're someone who's never attended, never bothered showing up, never applied, I'm going to go, well, how can I help you? One other thing too, I can tell if you've assessed the online material. When you do assessment 1, if you haven't been spending some time on the online material, I might not mark your assessment. Why would I mark someone who doesn't bother putting some time into learning more broadly? If you're just going to learn for the assessment, I'm not very motivated either. But if you're going to learn more broadly and then apply it in the assessment, great. So beware. With the week topics, so yeah, it's oh, sorry, Luke, thank you. That is really remiss of me. So in the grade centre, we have short quiz week 1. I haven't changed the quizzes. 9 tomorrow. You should be able to open it still. But yeah. Oh, sorry, I'll quickly do that. So yeah, that sort of question. Miss, you've been slack, you haven't updated these. And so the week, what are we in, July? How did it become August? Okay, weird. So it'll be due by then. So the way that the unit is structured, and I'll fix the rest of the quiz later, is you've got, that's the thing I always forget. You've got the pre-work each week. Where's week 1? You've got some sort of pre-work. You've got an overview of what you're doing this week. You've got the slides for you to look at before class, please. Then I put this question topic, which is actually supposed to be a question on the topic, on the slides, if you can. Or in this case, it was over. Where's the pre-work? Yeah. So I will go through the pre-work very briefly, skimming. But I expect you to have done it each week, looked at it, and ask questions if you don't understand it, and I can focus on that. And then we'll do the slides, and again, I hope you've looked at them before, because there's a lot to go over. So I've put this up it's the familiarity of big O notation. That's the way we talk about complexity, is big O. So we'll be doing that a lot. So chapter 1 and 2 are background to Python or programming. You should have read chapter 1 and 2 of the textbook so far. Chapter 3 is first week. Then I gave you this, activities. Yeah. Yeah, so complexity is, computation complexity or space complexity, 2 issues we look at. Most commonly used notation for describing that is big O. So that's what we'll be doing. We'll also be looking at this issue of problems where the complexity is so big you cannot solve it in a reasonable amount of time. So polynomial or non-deterministic polynomial. So is NP. So PNP is the polynomial non-deterministic polynomial time. The NP problems, non-deterministic, means Unless you choose an answer and try and verify the answer, the problem will not be in polynomial time. But we'll go more into that later. So it's not exactly non-polynomial, it's non-deterministic polynomial. So I'll explain that. So moral imperative. I know you're motivated by intrinsic motivation is not necessarily what I want, but I'm hoping some of it will be improving your coding or starting to code or understanding coding, understanding complexity. And we deal a lot with Euclid's algorithm this week. So you'll get to know that. Pseudocode, I encourage you to write pseudocode. I've given you this as an exercise to understand what pseudocode is. What do we mean by it? It literally is a logical structure in any version of English with any syntax, but as long as it's clear. So the syntax must describe the components of your program. So if you have a for loop, it must have brackets or something that show what's in the for loop and then when you come out. So it's just a readable piece of semi-code material. Oh, sorry, I thought the problem was in here. No, that's myself. Week 1, pre-work overview was the overview? No. Yeah. Complexity calculus. Where did I put the question? There was a question. There's a person who's going, I can't even find it now, it's bizarre. It's a problem being in front of people. The question you would have seen was that there was a person who goes to visit 2 grandparents on trains that go opposite ways, and the trains run every 20 minutes either way. And they go to one after about a few months, one of the grandparents complains because they're visiting them more than the other grandparent the other way. So the problem is this in this course? Just to see. Oh, sorry. I just realized it's the other course. You will notice this with me. I'm teaching 2 courses who are very similar. I'm teaching them on the same day, and I will suddenly slip into the other one. So please, if you go, miss, I don't know what you're talking about. That's why I can't find it. Okay, I will not bother you with that problem. So we do a lot about probability and logical thinking. It is actually an interesting problem. It's a logical problem. So because that's the PR 580, which some of you are doing, and it requires a lot of logic. So as I said, one of the things we do a lot is the greatest common divider. Does anyone know what a greatest common divider is? Probably not at school. So if I've got 5 and 20, what's the greatest common divider? 5. If I've got 6 and 20, what's the greatest common divider? 2. Yeah. So it's the number the largest number that will divide into both of them. The lowest common multiple, 2. So the lowest common multiple, we divide into primes and multiply all the primes that are in common, and you've got the lowest common multiple. Same thing. Reason we're doing GCD is it's something that we can. There's neat algorithms for doing it. So it's a way of improving your code. So it's an example we use for the first week or so. And I ask you to do a question on that in the assessment, which is basically, does this code work? So the other thing too, I provide you with Python code. There's a Bitbucket account that has it in. I'll show you the whole account soon, but that's different code for the GCD, and you can run it and get the answer. So this is code you can practice with. I'm encouraging you, even if you don't do coding, to grab the Python, start using it, and do it on Visual Code Studio. I did have that. The reason I say Visual Code Studio is it has a lot of support for programming, particularly Python, which relies very much on indents. It's very pedantic about your alignment of lines and can be a pain. So do use something like Visual Code that helps you. And this one is factorial. Is again the same factorizing code, same thing, and I've done it showing the time it takes. So you can actually use code to see the actual time your code takes, and you see that it grows or is more or less depending on the way you've coded it. So I'll be running those. Where are we? Oh God, it doesn't go back to where you were. Well, not very helpful. So, yep. The other thing too, I put up, I hope here. Oh, no. It's in the workshop, I think, is it? The repository link. So I've put you the link to the original repository, the whole repository. Do a Git pull of this. If you do not know what a Git pull is, or you're not done any programming yet, this is the link of the week 1 instructions, which is how to use or Bitbucket. It's only a pull, you're not pushing, so it's very simple to download all the code. It sets you up to link into the Bitbucket or just do a clone. So just a few. I'm a programmer too, and I do the programming unit, so I'm really keen that you start getting used to Git pulling, Git cloning, getting used to the Gits. So if you clone this repository once, link, you go to here, clone, you copy that link, you clone it, and use the HTTPS, not the SSH, just out of interest, because that helps. Again, I might better put that up. Each week you can do another Git pull. Yes?
Yeah, I'm not sure that the offline student is because you just share only one tab of the browser.
Oh, it only shares one tab.
Yeah.
How? Sorry.
You can share again and you do the entire window.
Yeah.
The back tab. Yeah.
That's ridiculous. Window. Yep. Yep. No. Yeah. All right. I'll share entire screen. It's probably safer. You're right. This is going well. Thank you. Yeah, I usually share entire screen, just different venue you get. So yeah, well, I'm going to do an extra video on this stuff because it was so broken. So the repository link is under the week 1 workshop. Do go to the repository, each week you'll need to pull. I'll add more weeks code. I'm just adapting it. I'm still adapting the slides from last year. I'm not reusing exactly the same. But that's all the Reveal.js code for that slide that I showed you here. Yeah, I can actually see it there. I can check what I'm doing. That was why it's there. It's supposed to be used. And this gives you, background how to do a clone. So go to clone and clone it. Clone in Visual Code Studio would be great. And it will give you some instructions about setting up Bitbuckets and stuff if you just go to the link. So each week you can download the Python and play with it. Where are we? Complexity calculations. So that's the slides for this week. I might be better if I download it actually. Or no, I was going to do it from the other way, but I forgot this thing that it makes it smaller. Okay. And this is where I've really got to share my screen or I'll forget. Yeah. So yeah, that's going well. That's good. Okay. You can use code for this unit. You can use code or pseudocode. We're looking at complexity. We're looking at coding structures and data structures, because the data structure helps you do the coding. And we'll do a pretty good example of that towards the end of the unit today. Common algorithms for search and sort, we go through a lot. Searching and sorting, we love. This is focused a lot at big data sets. So if you've done calculation like AI still does big data sets, but a lot of functionality programs little apps dealing with one user. You're not dealing with large data sets. This is mostly focused at large data sets where we talk about the data input size is n, and n is really large. So that's why it becomes a consideration what the structure is of the data and how complex your program is. Makes whether your code runs or not, or spends the next year running. Yes, hide, please. And the reason we're doing this so you can be a better coder. So even if you're learning coding, it doesn't matter because you can do it better from the start. So what is a good algorithm? Well, there's various aspects of a good algorithm. Good algorithm is one that you can read and the other teammates can read is a good algorithm. One that does the job in the least number of steps, both coding steps and like lines of code and coding steps. How to organize your data for an algorithm. So when I do this concept slides, this is the sort of thing I test in the oral, but I do a revision in week 12 to remind you of the sort of things. So how to improve an algorithm and test it is improved. So that's why we do this time testing and check that it's improving over time. Oh, I think I'll get to later. And how to write algorithms in different ways. So you've got more options of how you can write algorithms. We do recursion, things like that. So the idea of this algorithm is normally for the people, it's a black box. You put in the input, you get out the output. You'll be improving that black box for others. So you can do it in any program language. We'll provide you with comments, pseudocode, which is informal high-level description of an algorithm. Pseudocode is step-by-step, typically a mixture of English, mathematics, and programming constructs. And this level of detail of pseudocode should be enough for allow analysis of the efficiency of the program. So don't just give me an algorithm description, which you can, it's okay, you say, okay, this algorithm will find the maximum element of a list. Great, but how will it find it? I need to know the steps so that I can calculate the efficiency. That's why you do pseudocode, not describe the algorithm. So there's a difference. You need to give step-by-step process. And then we can look at the time and the space complexity because we know what the algorithm is doing. Running time, most algorithms transform input objects to output. Running time algorithm typically grows with the input size. It's a function of n, the input size. Average case is often difficult to determine, so we focus on the worst case. Obviously, we want to consider the worst case because then we can justify, yes, our algorithm will run in log n or n squared time or whatever, no matter what the input. So the worst case is the most useful one to focus on. So this is just some idea of the distribution of best worst case can be quite varied. And running time has no unit, which is really important to understand. Your running time unit will depend on the computer you're running on. So when we say the running time of this algorithm is, we say order n, we don't say n seconds, because it depends on the machine you run it on. So all we can say is this algorithm is order n, that is order log n, that one will run quicker than that one on the same machine. So that's all we can do. So yeah, in games, finance and robotics. Finance because we deal with large data. Robotics partly because, yeah, we deal, particularly with images, we deal with large data again, but also you want quick response to interactions. The robot should respond immediately. And in games, we want quick response to players. So experimental studies, we've done experimental studies on how these algorithms work, and we'll do a quick one. So from time, input time, start time, run algorithm, end time. It's basically the concept where we set up, grab the initial time, grab the final time and subtract them, and you've got the time that algorithm took. So we can do we'll do that this week, I hope we get time, and do it with various input sizes, and you get these plots. And so then you start to get the idea of how the efficiency changes with the data, and you can then say what the efficiency of this data will be depending on the input data size. But experiments obviously can't be done all the time and they're fairly limited. So it might be difficult to implement the algorithm with a particular data set that you will match what you're going to be using, and you've got to time it. They might not be indicative running time on another type of input, different data structure, something. So to compare two algorithms, the same hardware and software environment must be used if you're going to do it experimentally. So while we do some experiments to see how data size affects the running time, we don't usually do it that way. We use theoretical analysis. So that's why we're doing a lecture on complexity, because it's theoretical. It uses a high-level description of the algorithm rather than implementation. You don't need the code to do it. Calculates running time as a function of input size, takes into account all input sizes, or possible input, sorry, and allows us to evaluate the speed of an algorithm. So we can just get an estimate. Data of size n comes in. Oh, yeah, and then space complexity. That's the other issue. I mentioned time a lot, but I also mentioned space. So if you've got data of size n coming in, you don't count that initial size. That's already, the computer's already has to store that. What we're worried about is how many times it gets restored, how many copies you make. So how many copies of the data are stored, and this will define space complexity. So space complexity is the number of times you copy the data. So the data is stored in different arrays of size n on 2. The space complexity is n times n on 2 minus the original n, or n squared on 2 minus n, as you subtract the original array. If data is just stored in array size n, the complexity is defined as 1. So we're not expanding it, not adding to it. So this, like I said, about pseudocode, less detailed in the program, but still defines the steps you'll take. It doesn't show you all the program design issues, the complexity of the syntax, or other sort of neat tricks you can do, because they still have to do the same steps. It's still the same complexity. So this is an example of pseudocode. You need some sort of control flow, which is, if then else statements. So control flow is how you control the program through the steps. So if then, we'll select a conditional, which step you take next. While will tell you how long you keep doing something, repeat, etc. So again, you use different expressions. So while and repeat are pretty much the same process, but you can call it something different as long as it's clear what you're saying to do. So again, you should declare the method, algorithm method, input, output. It's got to be clear to the reader, which might be your teammate or me, the marker. Call methods, return values, etc. So these are sort of aspects that a pseudocode will have. So what we're dealing with is, and we actually deal with data structures too in this later, but in terms of, we're dealing with a random access machine, RAM model. This is how this is the other thing. I don't know if you've ever wondered how that computer thing works, what it looks like inside. Have you ever taken a computer apart, looked at the components of a computer? The RAM is the random access machine, which is the memory cells of the machine, can hold arbitrary numbers or characters. The memory cells are numbered, and accessing any cell memory takes a unit time. So this is where our time starts. Accessing the cell to get the data is one operation that we need to consider. So that's the complexity one, is to get the data. And then we start looking at all other operations. So this is part of when we start adding up the complexity, starts with actually getting the information we're going to work with. So it's all very step by step. But we hope that this is complexity one. And I'll reiterate this a lot, but any operation that we do repeatedly in a program, such as access data, must be complexity one. If it starts to be complexity n, well, it can't be because you're only accessing one data at a time, but you will then by default have a really inefficient program. So we start off as optimal, all the important operations we make optimal from the start. And so the things you will get used to by the end of this course, you'll be rattling off, oh yes, this function is order log n, order n squared, or n cubed, quadratic, exponential, order 2 to the n. 2 to the n are one of those functions that we don't want. Obviously, it expands much too quickly. So this is the sort of range we look at. We're not worried if it's log n plus 1 or 2 log n, and we'll be doing this today, but we're just worried, is it basically log n? So we simplify. All we want is the shape of the curve, literally. So that's down the bottom. That's the linear one, that's a quadratic, and that's a cubic, because it's on a log scale. Is it? Yeah. So that's why they're straight lines, but it's why we draw them, because it gives you some idea of the increase over the size. So functions using a normal scale. So this is the constant one. So the efficiency, the complexity. So I keep saying efficiency, it's the same thing. Complexity is order 1 for if it's order 1 for a function, it'll look like the complexity will stay constant. We hope. The constant might not be 1, it might be 100, but it just stays constant. If your complexity is log n, as n increases, your complexity will increase by this shape. That's why we like log n. It doesn't get too big. And if it's of order n, it does start to increase a bit. N log n is a little bit better, but a little bit worse. It goes a bit higher. And n squared is even worse, and so on. And 2 to the n is just ridiculous. It gets much too big. So that's the efficiency as n gets bigger. So the idea is we're looking at the primitive operations and we count them up. So basic computations, addition, subtraction, multiplication, you can find them in the pseudocode. So you can do it from pseudocode. They're generally independent of the programming language. So while some programming languages are better doing certain operations, that might be because they have compiled libraries that do those operations, but whatever, most of the operations will be the same across languages. Exact definition not important, and you assumed that it takes a constant amount of time in the RAM model to do these operations. So every operation is worth constant time in itself. Each one, individual one is, and then you add them up. So every basic computation is 1. So evaluating is an operation where you say, okay, I've got all these numbers, I evaluate what they add to, but within that you've got addition, subtraction, and multiplication. Evaluating usually is like n equals 10. Okay, that's order 1. So I shouldn't say n. I equals 10 is order 1. So assigning a value, indexing, calling a method, returning from a method, all order 1. So here's an example. Counting primitive operations. Find max inner data. Turn the maximum element from a non-empty Python list. The biggest is the initial value. So you're saying this initial value, you want to see if there's anything bigger than that. That's 1 for that step. For each value in data, so you will iterate this a number of n times because the data is size n. So if val is big, so actually use mouse. If val is greater than bigger, so that's a comparison 1, and an assignment is another one. Return bigger. So where's what? So 1 is so you're calling the so step 1, you're calling the algorithm, sorry, and the data, 2 operations. 3 is you're finding data 0, the 0th element, and you're assigning it. 4 is 2n because you, why 2n, sorry? Because for each n, you then have to assign it to val. So it's actually an assignment with as well as finding it. And for 5 is 2n because it's got to you've got to evaluate and then evaluate and then and also you've got to say where to go. So you've got to decide on next step. The 6 is 0 to n ops. Well, yeah, because if you count each one, so either you do nothing because you've stepped over it, or you're silent. And 7 is 1 op because return is 1 operation. You don't have to do it in this detail each time, because as I explained, and I'll explain again, we simplify it. 2 ops is order 1, 2 ops order 1, 2n is order n, 2n is order n, etc. So you're going to be simplifying it, but this is just a really detailed understanding of where we get this idea that, okay, this is order 1, even though even though this is 2 steps, it's order 1, and so on. So any questions on that? Or anyone? Yeah. Order 1, big O. Big O1. Sorry. Yeah. I only realized that halfway through last year. I'd call it order 1, and it's actually big O1. So apology. It's because I've been used to it for so long. That's probably how I was taught. It was order 1. So order 1 is big O1. So this is 2 operations. So if it's 2 operations, it's big O1. If it's 2 n operations, it's big O(n). So the order of the operation is n. Same thing, exactly the same. But sorry, I'm using different jargon. I'm supposed to teach you to you as big O, and I think of it as order. So do catch me out on those sort of things. Thanks. So estimating run time, find max. If you add it all up, executes 5n plus 5 primitive operations in the worst case, and 4n plus 5 in the best case. So 5n, where's the n? So it depends on 6, it can be 0 to n operations. So in the worst case, that will be n operations. So you'll get 5n, and otherwise you'll get 4n. Time taken by the fastest primitive operation, time taken by the slowest is B. So if Tn is the worst case time of find max, then the fastest primitive operation, so whatever is all those primitive operations we talked about, accessing memory, assigning values, all those have a certain time on this computer, imaginary computer. So if we give it a value A for the best case and B for the worst case, then we multiply these, we know that Tn will be somewhere between those. So it's bound by 2 linear functions. Again, we don't mind because these are the same big O function. But I'm just going to real detail. So hopefully those of you visualize things very concretely will see the very concrete way it's set up. But then we become abstract and say, okay, we can round it off and we can be much more. So changing hardware software will affect Tn by a constant factor, as you saw, because the A and the B will change. So there'll be a constant change in the worst case timing. The linear growth rate of the running time is an intrinsic property of the algorithm find max. So no matter where or how you write find max, it will have the same big O for Tn. That's the idea. So yeah, just some iteration of why it matters. So if I've got some constant for this machine, there's the constant A or B or C, that's constant operation time, worst case operation time. If the runtime's C log n, if I've got n plus 1 or 2n or 4n, how does it increase? If it increases by n squared, you see it increases by a factor of 4, 16, etc. You see the quadratic effects, the scale of the growth. You can see that. So this is where I'm looking at n increasing, not the complexity, but the actual n. As my n increases, the complexity will increase. And this factor matters. We can't smooth that out at all. So this is n increasing. And if you've got a complexity of 2 to the n, as n increases, you will get a ridiculously large runtime, and you won't be able to produce an output. I used to work in, I initially started as a punch card operator. So we punched the cards, we put them into the machine, sent it in overnight, came back in the morning, oh, there was an error, and you start again. So very slow. So you're really lucky now. You've got development environments that help you code really easy. You can see what your punch card's written much clearly, etc. But now we're starting to, so that's all sorted, but now we're looking at AI, where we look at large data sets. And again, the complexity grows. We need supercomputers to actually run them in a reasonable time. So this is very relevant today. So comparison, insertion sort, merge sort. Someone in the pre-work already knows insertion sort. So remember in the class there are people who already know insertion sorts, merge sorts, all these things, types of sorts. These, when you compare them, the insertion sort is n squared over 4, the merge sort is 2n log n. Obviously much more efficient. That's why we teach you the merge sort. Works better with some sort of data sets, not others. So again, it's okay, is this applicable now? Is it not? Etc. So I give you some idea of, insertion sort takes 70 hours for 1 million items, while a merge sort takes 40 seconds. Quite a difference. We're trying to improve your code. So constant factors, just trying to emphasize to you that these constant factors are not counted because they're not significant in terms of the growth. So whether you're, this one is 10n squared plus 10 to the 5th is a linear function. And this, is that another linear? No, it's not. That's another linear. Quadratic, linear, quadratic. Oh, it's a log scale. Sorry. So on log scale, that's a linear, that's quadratic. That's another linear, another quadratic. Again, what we're worried about is how quick it grows. So it doesn't matter if we remove the constant. It's not going to affect the growth rate, which is what's significant, because this other factor will change with the computer. This factor will change with the computer, whereas the actual rate it grows won't change with the computer. It'll always be a factor of that function. So we say that Fn and Gn are ordered, or Fn is ordered Gn if there's constant, the C and n naught, such that Fn is less than or equal to C Gn for n greater. All it's saying is, if we've got two functions and one is always less than the other, we can approximate its complexity, its big O, by the larger one. Or sorry, by the one that, sorry, it's actually by the smaller one, but if you multiply it by another factor and it's still large, we can say that this one is linear after this point. Oops, sorry, don't click. After this point, this blue line is effectively as efficient as the linear one, just transposed by a factor. So that's all we need to know. All we need to know is the increase rate, the rate it increases. So I'm excusing myself and justifying why we do the sleight of hand, and we simplify it all down to say all we need is the power of n that we look at. So if you've got n squared, obviously there's no order n function that will be bigger than that after a certain point. It'll always end up smaller after a certain point. Yeah.
In
Yeah. So what we've got here is we've got a linear function, say, or 2n, yeah, 2n plus 10, say, and this one is c minus 2n, oh, great, 2n plus 10. So 2n plus 10 is this function. So that at the beginning, 10 will override. So that what happens is if it's just 2n, it's 1 at the big log is 1. But if it's 2n plus 10, you get this extra factor at the beginning. So it starts off larger than your approximation. So I'm going to approximate it by n. But at the beginning, it'll be bigger. So what I say after a certain point, this point here, it will be the same as that multiplied by a certain factor, which we're saying is 3. So if we multiply it by 3, that dotted line, which is just a transpose of that one, will be bigger than it, always now, we know. So we can say that this blue line will always be less than the dotted line. So it's valid to say, in worst case, this function 2n plus 10 is less than c minus 2n. Oh yes, less than 3n for n greater than 10, or n naught is 10. But if you've got n squared, obviously I cannot find a transpose of this function up to be bigger than that n squared always. Anytime n squared will surpass the function or the multiple of n and shoot off. So that's why we differentiate log n, n squared. That's all we're worried about because it's how quick they grow. So if I want to find the big O for 7n minus 2, what is it? N, order n. For 3n squared plus 20n, sorry, 3n cubed plus 20n squared plus 5, what's the big O? N cubed. And for 3 log n plus 5, the big O is log n. Yeah. So you just remember those. It's got to fall into 1 log n. Yeah, so the answers are there on the slides if you need. So polynomials of degree d, you understand that polynomial of degree d means it's n to the d is the largest factor in that polynomial. So it's got n to the d minus 1, etc. all the way down, but n to the d is the largest factor. You can drop the lower order terms, as we did in the second one, and say, well, they're not going to increase as fast as the larger order term, so that's the big O. Just a sec. Oh yeah, the other thing to be careful of, in effect, so I've got my one saying this line. You can say 2n is big O(n), but you can also say it's big O(n) squared because it's smaller than n squared. This is the problem with worst case. Order 2n is definitely better than n squared, but you're losing a lot of the value of your function. So don't approximate that. Do find the smallest one, smallest function of n that contains, worst case contains that function. And again, don't say it's order 3n, say it's order n. You can drop the constant and drop the lower powers. So find the worst case. So find max runs in order n time, find the constant factors and low order terms, eventually dropped anyway. So we can disregard them. And again, a few examples of running times where for say, if it's log n and you've got data of 10 to the 6, it will take 20 microseconds. If it's n log n, it'll take 20 seconds. And if it's If it's cubic, it'll take 31 years, etc. So we do want to avoid these functions. I mean, okay, 10 to the 6 is an enormous data set, but still, we are looking for some of this. Another example is prefix averages, just because this is used in finance. So example, the ith prefix average of the array X is the first I plus 1 elements of X. So we're looking at the average of the ith item, then I plus 1, I plus 2, so on. So average up to the end. Computing an array A of prefix averages of another array X has application to finance. So this is an example of prefix averages, where A is the blue values and the prefix averages are in pink or something. There is an example of code for it. So you start with, you have to set up, again, coding is a bit more complex than pseudocode. You've got to set up the data structure. So you set up the array of zeros size n. Arrays, as you will have to learn, have to be set up before you use them. So, list. Arrays don't. Lists have to be set up. So you as you go through, you can, I'll just see if I've done it. No. You can say that the total increases from that, and so you're doing it step by step. You say, every time I'm looking at a prefix average, I do calculate each total of all the previous numbers and average it out for that AJ. So I calculate each one by one. There is a more efficient way of doing it, but this is just the first example. That's how you calculate prefix averages. So prefix average 1 is order. So if the first one you calculate, there will be one calculation here. The nth step, you'll be calculating n. You'll be summing n items. So the order will be 1 for the first time, 2, and so up till n times, and then I'll add them up. Now, I'm going to do a sleight of hand. The sum of that is n times n plus 1 over 2. These are sort of things you have to remember. I can prove it. You can prove it quite easy. What you do is you add n and the 1, and then n minus 1 and the 2, and you find you've got n on 2 times n minus 1, which is literally that, or n plus 1. N and 1, n minus 1 and 2 is n plus 1. So yeah, so that's you need to know this, and also at the end of today I'll show you this in closed forms. You need to know how to add common series like this. There's a geometric, the arithmetic bar. You just have to memorize them. So that's why I started this week. I'll give you the table. So given that I know that these are the sort of steps you're taking each time, I know that this is the number of steps I'll take for a data set size n, and it'll be order n squared, big O, n squared complexity. So now I'm saying, well, I could simplify this, because every step I was summing the whole series, previous points and adding a new point. So what I'm going to do is so I can't remember which step I did which. Yeah, if I'm using an internal function, sorry. All I've done is call an internal function, like a library function in Python. So it's pre-machine compiled. It's effectively should be more efficient. It still runs in order n squared time, because this is still, the sum operation still has to go through the n data points. Even though it looks more efficient, it is still the same efficiency, slightly less, because the machine will do, that is where the machine factor comes in. Machine will do this more effectively because it's compiled, but it will still take order n squared, big O n squared. However, I can do it in linear time. So as I was saying, if I have already got the previous total of the previous items and keep track of that and divide it by the new number of items. So total is 0, and I'm keeping track of the total. So every step I go through, I add a new element of the array to the total, and I just keep that total going. And then I divide it by the number of steps at that point. I'll have the average. So I'm keeping the same total going. I don't have to keep calculating the total. So every time I only add one item. It's sort of thing when you look at your code, you think, oh, that's really inefficient. I'm adding the same numbers every loop. Well, I could store the numbers I added previously and just add another one, and it runs in big O(n). So these are sort of things we're getting you to look at, think at it more logically and quickly. So the sort of maths you will need to review is how to deal with logs. Log of two numbers multiplied is the sum of the logs. Log of a constant, A and B are also conventions. Again, I am speaking a language that is mathematical. Don't be put off by that. It's not a complex math. It's just a jargon for me to express ideas more quickly. And you need to learn that language to hear ideas more quickly. So A and B and C are generally constants. X, Y, and Z are variables. And so this is sort of assumed in here. I realized, oh, I assumed this when I wrote. So when you say log XA, the constant can come out because it's not, it's constant, it's not varying. And log of, if you want to change the base of a log, like we go from binary to decimal or back, you divide, say log of A base X divided by log of B base X is the log of A base B, things like that. So again, these are sort of, and exponents sort of complementary sort of properties. So anyone not vaguely familiar with these logs and exponent laws? If there's something sort of like that that okay, something like that that I sort of brush over and say, look, this is jargon that I need to know. There are tutors online. There's like tutorial assistants online that you can go and get for things like that that are generic. I mean, you can get it for anything, but this might be a good opportunity to go for. The other thing is, I'll check if there's examples in the book. Might be some examples as to use them, or go and look on the web and, okay, give me some examples where you use these. Again, it depends on your learning mode. I learn by doing something. So I would go and do an example. Others might learn by reading why these are. Why does log xy equal log x plus log y? So that you can always remember, this is the process that you're undertaking. So I can remember that. Others, might just do it by seeing examples done. I have to do the example. So there's different ways. So depending on what way you learn best, please do go through this. So that's in slide 36. I think the last slide on this. No, not quite. No, nearly. Not even total. So slide 36. There's some examples. So go through that. So we've got big O. We've also got big omega. And so big omega and is that the function is the best case. So that the function is always greater than omega, the omega. So G, the G of n will be the omega function, and that will always be less than the one. Not always very useful. So it means that your function will always be worse than that, but it means you can prepare for sort of something that will be, at least be the baseline. And big theta is something where your function is between two constants. So it's bounded above and below by a function. It has to be the same function. So it could be n squared, n cubed will be less than it and greater. So it might be an oscillating, your function f might be oscillating as long as it's always kept within bounds of these two things. So we'll show you. So big O is Fn is asymptotically less than or equal. Big theta Fn is asymptotically greater than or equal, and big theta is it's asymptotically equal to. As I said, we've usually used big O, but occasionally I might ask you for the big theta, so just be careful reading questions. I do that because reading questions, reading requirements is really important in programming. No point answering the question you'd like to answer. You've got to answer the question you're asked to code. So 5n squared is omega, big omega n squared. Yep. Of course, it's always going to be bigger than just n squared. I mean, it's pretty obvious. 5n squared is big omega n. Again, trivial, not very helpful. It's actually much bigger, but it is big omega n. So it'll be 5n squared will be big omega n, big omega 1, constant, big omega log n. Not very useful information, so that's the first one's probably the most useful. Oh, thank you, Michael. Yeah, and I will do it in the break, which will be very soon. And again, 5n squared is big theta n squared. You've got, it's bounded between two n squared functions, 6 and 4, for example. Sorry about the use of Greek letters. That's what we use in maths, because the English maths derived from the Greek maths. We ignored the Babylonians and all the work there, burnt it down, I think. So yeah, a lot of it was predated, but that's what we're basing our maths on. So. Again, another maths that we will use a lot is things like geometric sum and arithmetic sum. You should know these. So if a geometric sum is where every item is multiplied by a factor to make the next item. So 1, 2, 4, 6, 8, and adding them up makes the geometric sum, and that is what we call the closed form. So again, I'll show the closed forms at the end of the geometric sum. And the arithmetic sum is where you add, so that you multiply by the same factor each term. This you add the same factor each term. So I'm adding 1, and then I get that. And you can prove these by induction or contradiction, showed, but you don't need to. You just need to know what they are for your use. Quickly, the greatest common divisor or highest common factor. So the way we'd normally calculate it is we divide it up into its prime numbers. Does everyone know that the prime factors of a number are unique? These sort of rules. If you divide a number into its prime factors, that series of prime factors will be unique because they're prime. You can't divide them anymore. So that's a reliable way of working out the greatest common divisor, because you've got all the prime factors and, oh, sorry, I'm skipping ahead. These are the factors. The factors of 12. Yeah, I'm making it a bit simpler. I mean, a bit harder. So let's do it simpler. So just the factors, they don't have to be prime, of 12 are 1, 2, 3, 4, 5, 1, 2, 3, 4, 6, 12. And the factors of 8 are 1, 2, 4, 8. So those are the numbers that we'll divide into them. The common factors we can see are 1, 2, 4. So the greatest common factor is 4. And you can do that, sorry, why primes the other unit. If you do it by primes, the prime factors are 1, 2, and 3. And the 2 is repeated. So it's 2 2s and 3. And so the prime decomposition of 12 is 3 times 3 times 2 times 2. And this is 2 times 2 times 2. So the common factors are 2 times 2, which is 4. So that's the other way of doing it, sorry. So Khan Academy gives some examples of, this is for you to follow if you want to watch videos to clarify what's been gone through. Partly my problem is I'm teaching some people who know a lot of this already, and that might be why you're yawning. Some who don't know much at all, so it's sort of trying to balance between them. So there's extra resources if you want. Has a neat example in Maths Train, and I've gone off too much housework this week, so I won't go into them too much, but maybe more videos later. So algorithm of finding GCD, input A and B, set the value of X to A and the value of Y to B. Again, explicitly assigning every operation that will take a time. If X is greater than Y, then set X to X minus Y. If X is less than Y, then set Y to Y minus X. Repeat steps 3 and 4 until X equals Y and output that value. And one of the questions is this the greatest common divisor in the assignment? So it's a neat little step, but you better assure yourself that it is finding the greatest common divisor. That's why I ask. So write that pseudocode in your preferred programming language. And that's my preferred programming language. This code is given to you in that repository. So any code I show up on the screen is something for you to read, but if you want to run it and check it, it's in the repository. But it's just the reason I can do is show that what it does is adjusting Y, you subtract X from Y and down until Y is 47. Yeah, so now, so Y, only at this step, Y will be bigger than X. So you'll subtract Y from X instead of X from Y, and you'll get 7, and they're both 7, and you will get 7 output. So it's supplied on LearnLine. Well, it's actually now supplied in the repository, so even better. And you can run that. Shorter algorithm, so that was just doing a subtraction. So you subtract from the larger value. This one is finding the remainder, so it's using a library in Python. Does everyone know? Oops, sorry, what did I do? Yep, thank you. Everyone know this symbol, the percent sign? It is a modulo, or it was a remainder, sorry. Sorry, So the remainder is mod B, but that's a remainder. So modulo is again another thing you need to get familiar with. We use it quite a bit, partly because we do this problem a lot. But the idea is how much does B divide into A is the modulo, and the remainder is after that division. So if I've got 54 and 8, 6 eighths of, 6 eighths of 48, leave 6. So the remainder is 6. So I'm doing a rapid subtraction and leaving the remainder. So what I've done is I've subtracted 8 from 54 6 times and got the remainder, 6 times and got remainder 6, confuse me. So it's the same as the other one, but it's much simpler because I've called a library. However, it will be the same efficiency. So that's exercise to prove the pseudocode. We'll find a common divisor. That's for your assignment. Prove 2 that this is the greatest common divisor. Oh, sorry. That's the assignment. Prove that it's the greatest common divisor. We don't want to do an operation and then not actually get what we wanted. That's why I'm getting you to do that. The extended one is the extended Euclidean algorithm. This is used in cryptography. That's why we're introducing it now. Once you've got the greatest common divisor and you've done it through this process, you can actually find an equation such that the X, which is the, just a sec, turn GCs. Yeah, so the greatest common divisor is now become X, not very good. Oh no, it hasn't. Okay, so the greatest common divisor is X times A plus Y times B equals G. Yeah, so I had to turn it around. So through all these steps, you come out with the greatest common divisor. You can then find it in an equation where it is a sum product of the original two numbers, which is very useful, but we'll get to that at the end of the class, of the 12 weeks. Yep, oh, sorry, here we use. So the computation of the modular multiplicative inverse. So that's essential step in decrypting key pairs in the RSA public key encryption. RSA is the main encryption we use until we get quantum computers. Extended Euclid algorithm applied to two coprime numbers will provide the modular multiplicative inverse. So that's the modular multiplicative inverse is the GCD exactly, or yeah. Yeah, so if GCD is 1, so often the only common factor is 1, if they're mutually prime, then this will be 1. So you found two variables, is A the originals or? Yeah, so we've found two variables X and Y, where A and B will be, yeah, because X and Y are the variables, where A and B will equal that 1 because their common prime is 1, the only one. Inverse of A is X mod B in a multiplication sense. So that's why we call it the modular multiplicative inverse, where mod B, A, and X is 1. So if you take the mod of both sides of that, that's 1. Mod of YB is 0. And so XA mod B will be 1. And that's it. Now, the workshop will be the next half. I'll give you 10 minutes break. Some of you need toilet, sorry, maybe I do. I need a drink. Any questions I want to ask? So, oh wow, I did get it in time, with all the stutters and stops. In line, any questions? I will mark the online people now, attendance, so you can see me do it. It only had a short time, so I'll do it now. I've got to stop sharing. So I'll stop sharing. Yeah, I'll just put it up now. Just I kept.
Sorry.
No, why was it? The problem with this, it didn't know how to stand or it wasn't standing.